Okay, I'm going to continue where I left off. So we were here. So yeah, we have a big graph, and we want agents to work on this graph without clobbering each other's work. It's a very similar class of problems to imagine multiple agents working on a code base. It's perfectly fine if one's working on, CSS styling of a component and another one's working on, maybe validation logic on a specific type of model. That's fine. But two agents working in the same file, again, totally fine to do. But the types of locking and the types of hierarchical retrieval that you're doing on each of those is a little bit different. And so you want to have you need a flexible model. Different things do different things. And again, I believe that anything that I'm talking about here that involves this particular graph database, Neo4j, could be done with a relational database. It's just really interesting to think about the graph itself as the execution medium of the agents, rather than just a data store, because it becomes really useful. Imagine if you could visualize, chain of thought rollouts directly in the graph with a simple retrieval over a graph API. So I'm working on a blog post about the object graph API, but for now, we're going to think about just this tool management layer. So we have a graph, and there are a couple dependencies that we need to still think about. One of them is an embeddings API. So I deployed my own that I use that has a... I'm just going to wait for it to load. Let me just try to do an embedding. Maybe the load model. So here I'm hitting this generate embeddings endpoint, and what it does is it takes each of the texts. It might read. I don't think I do any chunking. There's a context limit for each model. In this case, this is just BGM3. But this would be a good place where I could introduce the clip, these clip embeddings. I happen to have like a couple $100 in credits. So in any case, I have this text embedding model, BGM3, and what I can do is what it does is it's kind of like it's creating like resources that'll exist also in the graph with this ID. I won't show it because I don't think it is actually implemented, but that's the idea. So you have this content and you have the embedding vector. And what you can do is if you go to the bottom here, you'll see that what I also include as part of the embedding process, because generally when you're embedding stuff, you know you're going to need it. So, okay, what I do is I return these IDs and I return the score. And so let's say that I would do like, that's my sister's name. And let's say I recalculate these embeddings now with 3. What am I going to see? You guessed it. Actually 3 comparisons, right? So Arthur 1, 2, 3 and Arthur 2, 3, 4 are like kind of close. Arthur and Sophie not so close, and then Arthur 2 and Sophie not so close. So it kind of makes sense. This is important because, okay, this is important because you want to do like semantic retrieval. A lot of people kind of do what I showed in the previous video, where it's like, all right, this thing where I was querying about my father's knowledge base, right? There's this embedding that you need to do. In this case, what I'm doing is I'm doing a LLM generation and extracting keywords, I think, with a prompt. I'm probably embedding those then with a batch size of whatever 2 on whatever I extracted. It's like that's why schemas are so important. It's like you have the text, you don't know what's in the text. That's the challenge. It's like you need to find what's in the text without necessarily processing all of the text. And ideally, this entire loading pattern that a lot of people are implementing, themselves just with these AI APIs, right? This entire sequence of like the logic, eventually the model is going to get so good that it'll be able to just on the fly come up with the right retrieval strategy, depending on if it has enough context of like where to go and what's going on. That's why having systems that kind of bootstrap an environment that it can operate in that is almost separate from the core user query engine, chat approach. So in this case, we have this simple retrieval chat. Over here, I discussed that we need an embedding service. Another service we need now is essentially, well, I'm just going to introduce it now. The Tool Management API. Now, this used to be called tools.distributed systems, but it's more interesting to think of it as a registry. Now, what I'm going to do is, so this API is located, here, Arthur Collet registry. Integration. I'm gonna generate a diagram on the fly. Imagine a chat API. Okay, I just wanted to generate this diagram. Hopefully it does a good job, but we'll see. So the idea is that, you have your two-system architecture now. So why do I call it two-system? It's like, all right, imagine you have a chatbot. You love chatbots, and you have a chatbot, because everyone has a chatbot. Okay, that sucks. I put in $10. We're not going to use it for Claude Code. We're just going to demo the capabilities of Arcos AI Chat, which is a chatbot that I'm working on that integrates with this broader service constellation. You can imagine like 22 different services. Some are dependent on others, but it basically allows an agent to have task scheduling, retrieval over disparate knowledge bases, which may be constructed on the fly or by configuration by a user. It also, as you can't really see it, but deep knowledge graph integrations, deep ability to like really do stuff, and kind of moving at different fronts. But what I want to show now is just using this, right? What is the weather in Rockville, Maryland? No. What is the weather in Los Angeles? It won't be cached. So I'm using this Claude 3.7 model, but this chat, imagine it said Arthur Collet --chat.modal.run, just like the last one. So you have this registry API, and you have some unknown as yet, because I haven't talked about it yet, an integration server. And the integration server holds all of the implementations of these different tools. So you can see it's starting to get very close to the model context protocol, where, you have a server, it has a defined pattern of there are resources, like prompts, but then there are also tools, and those tools are basically exposing endpoints as tools, which is exactly what we're doing here. So as we can see, you can consider there's a chat API, there's a separate external tool registry API, and then we have an integration server that on deploy time synchronizes the implementations of those tools, which are endpoints. And it's not like I'm like repackaging those into like little like Python like objects like that will then like be called by the agent in some way. No, it's literally dispatching from the tool registry API, the registry API, to that integration server. So if it's up and it's running, the data should be in the graph. I'm skipping over the graph, but that's where everything's stored, right, as we saw here. And what I want to get into a little bit is so we have this tool API, and you can just imagine like, okay, you have this big fast API, and I think I rewrote. Okay, oops. Well, anyways, I don't care. There's not that much data in it, but we have a predefined schema, and this doesn't actually include the registered schema concept I'm talking about above, but this is kind of like the default implementation of like, okay, you have endpoints. So maybe it makes sense to look at the integration server first, just because that actually uses the tool management API. But it's very, very simple, as you will see. This is kind of like the only thing, well, I put a lot of my stuff on Modal. And so this is just the wrapper I need for Modal. But then if we actually go into the app, what you can see is, okay, simple, fast API setup, async EO, context lib, okay, whatever. What is this? Oh, yeah, this is integrations for Twitter. I defined a lot of these clients just in line to just because I was lazy. Hyperliquid integrations. And it's kind of like, okay, chat runs on like port 2012, but really, now with my broader web deployment, it's now running as like a publicly facing URL. And the tool registry API runs on port 2016. And then this integration server that exposes a set of tools that are useful for like my tasks as a developer, AI person, right? A code interpreter, Python, other languages, something that gives access to a file system, something that can allow you to run system commands, a lot of that stuff. In total, it's funny hearing that Manus AI, this new generalist agent, has 29 tools, because I've been pursuing a generalist agent approach for the last year and a half, building out an autonomous agent platform that really enables you to do a lot of things and bring your own capabilities. And so way before the model context protocol, I kind of designed this system. So what I want to do now is go through the tool specifics. So like this is kind of like the little kernel of the idea. So, okay, we have a deployed registry API here. And so you can imagine like I could just grab this URL and this open API schema and have an LLM like generate a working client. Do it yourself at home if you'd like. And here, this tool management API is available online. And here on the integration server side, you have this. You have this client. It's the tool management API. And so in your service, you can imagine like, yeah. So here in this integration server, right, app.py, you have the tool API URL, which here I'm like specifying as this 2016. And I'm saying like, hey, I'm a client. Like, this is what this is. Distributed systems integration API, right? And then you have the service URL here, integration API URL. And here, I'm defining a web app, right? Now let's copy this tools. Oh no. So what's happening here? Okay, cool. This is where it gets good. I have this thing and it's a decorator. We can see here like, okay, web app post. So this is a post endpoint. It has a defined response model. And here we have this endpoint defined as execute code with a specific input schema model and a specific output schema model. And then, so what's the thing that's unknown here? Well, it's this. It's a decorator. It's a decorator called tools endpoint. Now, if you remember, tools is this client instance that I defined of a, a client wrapper around this registry API that I have here. So registry dot, like basically I'm saying like this registry instance dot endpoint. So what does this mean? Well, this means that when you deploy your app, some magic happens and it will define this endpoint as a structured model instance in this graph. Yep, true story. All right, as you can see, there's basically a tool duplication where there's like 2 of each, but I don't give a shit. So here we have a tool called so now we think about schemas again. Tool has a specific schema. Tool is an idea, right? It's like, oh, I need to know where to call the tool. I need to know the params around the tool, and yeah, a description and a list of args is probably useful. So a tool has a type of action. It's like, how do you use this tool? Well, it has an action. The action, wow, look at that. It points to the integration server that, when deployed, will, immanentize these abstractions that the agent can use in a big graph that is retrievable over an API. It has an output type. This is kind of not really fully implemented yet, but the idea is that, like, you're going to want interactive visualizations. You're going to want an interactive canvas. Maybe you're going to want the agent to, like, call out to other systems and aggregate a response, and then also give options. Like, there's a whole bunch of other logic stuff that's going to be developed over the next 5 years. But here it's like, okay, it has schema. So really, I can retrieve over the tool with its more detailed agglomeration of capabilities with an action interface, a schema interface, and an output interface. But really, maybe I'm just going to retrieve over like the tool schema because it has an embedding, and the embedding captures a description and the arg schema, right? Boom. So in the same way that I showed you how we can do retrieval, in the same way that we can do retrieval, we retrieval over knowledge bases. We can do retrieval over tools if we get to, imagine some crazy person implements 129 tools for an agent, like this system does. Well, you have to do retrieval over those tools, maybe on each decomposed chain of thought, maybe on the actual taken trajectory after simulating a bunch of trajectories. A lot of things you can do, right? So here, I've kind of shown the flow. So you have a registry API, you have an integration server, you deploy the integration server. I guess I could show, yeah, I'll show that. So let's delete all the tools. Okay, you'll see. So basically, this registry, oh no, wait. So what am I doing right now? So I'm deploying the registry. Yeah. I'm going to delete all the tools so that we can see all 129 tools. Yeah, see, there's duplication. Sad. I'm going to bring up the registry, and then I'm going to bring up our client. Sorry, I get distracted. I'm just doing some quick Okay, so this is it. Registry's already deployed, so all I did was I deleted the tools. There were 425 of them. Fuck. And basically what it's doing is it's doing these batch registrations of tools. Wait, what is happening here? Okay, yeah, it's trying to batch register 139 tools. And hold on, I think I just exposed a key, so